Hi class, this video is going to have two parts. The first part is section 10.3 chords and arcs, and the second half will talk about tangents. So as a quick review, name two minor arcs on the circle. So remember that arcs are just part of the circumference. So a minor arc has to be less than 180 degrees. So for example, AB could be a minor arc, BC is a minor arc, AD is a minor arc, and DC is a minor arc. Name one major arc. Remember, a major arc has to be more than 180 degrees. So B, C, D. Looks like that could be just over 180. If you wanted to be for sure over 180, you could do D, A, C. That's a huge part of the circle. What is the relationship between the measure of the arc and the measure of the central angle? So remember, a central angle comes from the center, and the sides of the angle are going to be 2 radii. So say that I made A to the center to B, an angle right here. The measure of that angle is going to be the same as the measure of the arc. A chord is a segment whose endpoints are on a circle. So if you have a circle, a chord could look like this. A chord can go through the center of the circle, or it can just go through the side of the circle like this, as long as the endpoints are on the circle. Our first theorem is within a circle or within two congruent circles, two minor arcs are congruent, so this arc and this arc are congruent if their corresponding chords are congruent. So notice that the chords are also marked congruent here and here. So the arcs are congruent if the chords are congruent. You can also go the other way and say if the chords are congruent, then the arcs are congruent, or if the arcs are congruent, then the chords are congruent. You can go either way. Notice the central angles of those congruent chords are also going to be congruent. So in addition to the arcs being congruent, the chords being congruent, these two angles right here will also be congruent. The two circles are congruent. Given that minor arcs B, C, and D, F are also congruent, what else can you conclude? So if we know that this arc and this arc are congruent, we also know that those angles are congruent. So angle BOC is going to be congruent to angle DPF. We also know that the chords are going to be congruent. So chord BC is going to be equal to chord DF. Example 2. In the figures, circle J is congruent to circle K, and arc MN is congruent to arc PQ. Find PQ. So we know if the arcs are congruent, that these chords are going to be congruent. So we know chord MN is congruent to chord PQ, or that they're equal. So that means we can set their measures equal. 2x plus 1 is equal to 3x minus 7. And we will get that x is equal to 8. Now it asks us to find what PQ is. So we're going to plug in 8, and we will get 24 minus 7, which is 21. Next theorem. Within a circle or within two congruent circles, chords that are equidistant from the center are congruent. So, if these two chords are equidistant from the center point, then these two chords would be congruent. Congruent chords are always going to be equidistant from the center. So find the value of each variable using this theorem. So this is showing two chords that are equidistant from the center because they both have a distance of 9 from the center. So if this chord is 12.5, then this other chord has to be 12.5. Next one. I know that this chord length is 36, And I know that this chord length is 36. So if they're congruent chords, that means that they're going to be equidistant from the center. So if the distance to the center from that chord is 16, then this other distance is going to be 16. Now we're moving on to section 10.5, which has to deal with tangent lines. First, let's recall a few things. How do you name a circle? You name a circle by its center point. So if the center point is labeled X, it would be circle X. What do the angles of a triangle add up to? The triangle adds up to 180. A quadrilateral adds up to 360. What does it mean for a polygon to be inscribed in a circle? So if a polygon is inscribed in a circle, that means that the polygon, that's just a shape, is inside the circle. For a circle to be circumscribed about a polygon, that means that the circle is going to be inside of the polygon. So know the difference between inscribing inside of a circle and circumscribing about a polygon. Inscribe, the shape is inside. Circumscribe, the circle is inside. In either case, all the polygon's vertices and sides have to touch the circle. So let's talk about some quick vocabulary. A radius is the distance from the center to any point on the circle. Now a tangent. This is something we haven't talked about yet. A tangent line is going to be a line in the plane of the circle that touches the circle in exactly one point. So it's a line that touches the circle in exactly one point. So line AB is touching the circle at point B. A point of tangency is the point where the tangent line touches the circle, so point B would be the point of tangency. That's it for today. See you in class.